We'll do a conservative question now, but 3D. So the question is, you're given 2xz y sine x in the I direction, 1 plus cosine x in the j direction, and x squared 2z in the k direction. The easiest way to do this, again, the question is test for conservative and find the possible function. Okay, so the easiest way to do is gradient cross multiplication with the direction. So I, j, k. Here would be dy, ddx, ddy, ddz. Here we go 2x sine. Here we put 1 cosine. And here we put x squared 2z. You go I direction. Derivative of this with respect to y, there's no y, so derivative is 0. Minus derivative of this with respect to z, also 0. So the first one is 0. Minus the j. Derivative of this with respect to x, 2x. Derivative of this with respect to z, constant z is constant, no z, 0. Okay. We hide this. Derivative of this with respect to x is minus sine. Derivative of this with respect to y, nothing here. A constant y would be the constant. You'll see it's 0i, 0j, and 0k. So the answer is 0. Then it's conservative. So, if the answer is 0, then it's conservative. Now we find possible function. Possible function, you take the first one, you go, it's a function in terms of 3 variables. We integrate the first one, we call it m, dx. So you're going to integrate 2xz y sine x dx. Integrating this would be x squared z. Integrating this would be y cosine x plus a function g. This is integration x in terms of the other 2 variables plus a constant, we call it constant number 1. Okay? Function. Now we integrate n, which is the second one, dy. You're integrating 1 plus cosine x dy. Integrating 1 is y. Constant would be a constant y, so y cosine. Plus a function, you can call it k. This is y in terms of the other 2 variables, plus a constant 2. I'm going to erase some of this. Now, the last one, this, we can call it p. We're going to integrate this dz. x squared 2z dz. First one is x squared z, second one is z squared plus a function k. Now we have k, I, it doesn't matter what letter. This is z in terms of the other two plus c2. So now we can find possible functions. Possible function, like we did for the 2D one, anything repeated, you include one time. You see x squared z is repeated, so you're going to include once. You also see cosine, y cosine, so you're going to include once. The ones that by themselves, there is a z squared, there is a y, and then what's left are these functions, the I, j, g, and k, and the constant. You combine them all into a constant called c. This here is your possible function. This possible function we're going to need later on for another question, so I'm just going to put it here because we're going to need it for another question soon. So the function x, y, z, you have x squared z, y cosine x, z squared plus y plus constant. I'm just going to put it on the side. I don't know if you can see it. I moved this way a little bit. Yeah, I'm just going to put it on the side because I know it will be part of the next question. Okay. The next one is when they ask you to prove it's conservative and find the integral. Evaluate the integral. They're not going to tell you, I'll show you what the question means. The question means integrate this according to the curve, and they give you the function. They tell you it's 3x squared y squared yex ey in the I direction plus 2x squared y ex xey in the j direction. And they tell you that the curve, the C curve here, and they give it to you. Where t is between 0 and 1. Okay. When they tell you to do this and they give you the curve, first test if it's conservative. And I tell you in the question, prove it's conservative, and I tell you it is. So let's just prove it. To prove that it's conservative, it's only x and y, so you don't have to do the cross multiplication. The one in terms of x, find the derivative of y, and the one that's in terms of y with the j, find the derivative of x. So you find the derivative of this with respect to y. 2 times this would be 6x2y. A constant y would be the constant. The derivative of this with y is e to the y. The derivative of this one with respect to x now. The derivative, did I write it right? Oh, this is cubed. let's do the derivative with this with respect to x. 3 times 2, so 6x squared y. Derivative of this with respect to x is ex. Derivative of this with respect to x, a constant x is the constant. You'll see my equals nx. It is conservative. Now, if it's conservative and you need to integrate this, plug these 2 points into here. Find R0 and R1. If you plug 0 is only 2D. If you plug 0, that gives you 0 and 0. If you plug 1, it gives you 0 and 0. So it's conservative and curve starts and ends at 0, 0. Therefore, integral is 0. So if it's conservative and it starts and ends at the same point, it's 0. Good? Okay, so let's do another question. The other question, this is referring back to the previous, not the one before the previous one. It's the same curve, so the integral, it's the same one. So you see, it's 2xz minus 1 y sine x in I direction, 1 plus cosine in j, x squared z in k. This is similar to it's the same f and the one before the previous one. But now they give you a curve. T minus 1, t minus 1 squared. Here you say, well, what did we do for this one? We proved it's conservative. If you remember, we did the dx, dy, dz, we did the cross multiplication, we proved it's conservative. What else? We found possible function. And it was x squared z cosine x z squared and y plus constant, and that's what I wrote here. Now, let's see, does it start, they tell you it's for t 0 to 1. Does it start at 0, finish at 0? If it starts at 0, 0 and finish at 0, 0, then the angle, then the integral is 0. So, you plug 0, you plug 1 to see what you get. It's only 2 dimensions. Why is it only 2 dimensions? Am I missing something? Yeah, for the curve. Yeah, I wrote the wrong curve. Sorry. Let me just change this to the right one. It's t squared minus t e to the t squared. That's for the I. And t plus 1 et, that's for the j. And t et cubed, that's for the k. So again, we need to see, does it start at end at 0, 0, so of the same point, not necessarily 0, 0, 0, 0, like starts at 1, 1 and ends at 1, 1, or different points. We plug 0. 0 will give you 0 in the first one. 0 here will give you 1 times e to the 0, that's 1. And 0 here will give you 0. So 0 will give you 0, 1, 0. If this is the same point, then the integral is 0. Let's see. Plug 1. 1 gives us 0. 1 gives us 2 times e to the 1, so 2e. And 1 here gives us 1 times e to the 1, so e. So obviously it's two different points. So it doesn't start and end at the same point. In this case, your integral. This would be your upper point. This would be your lower point because this value is higher. You plug this into your possible function. It's like integration. So you plug it into this, the upper, minus you plug the lower. Plug the upper, 0 for x, cancel this. Here it would be 2e cosine 0. Z squared would be 0, and y would be 1. And the constant cancels out. So this is if we plug the, I plugged the lower point. We'll plug the upper point first, sorry. The upper point, 0 for x, cancels here, would be 2e, cosine of 0, cancels here, would be e squared, and y would be 2e. Minus, you plug 0, 1, 0. 0 for x cancels, 0, 1 for y, cosine 0, that's 1. 0 for this cancels, 1 for y, 1, and the constant cancels out. So the answer is e squared 4e minus 2. So this is the answer for how to do the integral if it doesn't start and end at the same point. If you prove somehow that it starts and ends at the same point, then integral is 0. If it doesn't, you have the 2 points, you plug the upper into your possible function, minus you plug the lower into your upper function. Forget about the constant, constant will cancel out. And upper minus lower would be your answer. So now what's left in this would be the Green's concept or the Green's theorem and the surface area and the idea of vectors. So, but I'm going to stop this part, and in the next part, maybe probably be the last part, we will continue with the questions. Okay? Yeah.